All right, everyone. Welcome back to MDE 61. Today, as promised, we're going to do more factoring examples, but this time I'm going to have them be just kind of in a random order. I'm not just going to give you a bunch of GCF problems and then a bunch of difference of squares problems and then a bunch of cubes problems and then a bunch of shortcut methods and then a bunch of AC methods. I'm just going to give you one word for the instructions, factor, and we'll have to figure out what to do. I'm going to be giving you a lot of time to work on these. So there's going to be a lot of just kind of dead air, like 10, 15 minutes at a time, because I'm going to give you multiple examples at a time to let you work. And then I'll go over them. As a reminder, what we said in Math 161 today was that we are officially going back to the classroom after this. We'll be in the A building. So 161 is going to be in 105. I did look that up. And I think this course, MDE 61, I believe that's going to be in lab A111, A111. Again, double check that in SIS just to make sure. But yeah, so we'll be seeing you in person starting on Tuesday the 1st. If we have to go back to Zoom because the administration says so later, then it is what it is. But I hope that that doesn't happen. That way we can get a little more interaction in this MDE course. All right, so let's not waste any time. And I could just say factor. I could say factor as much as possible. Those instructions would mean the same thing. And I'm going to throw 3 of these up here at once. And they could be super simple. They could be more complicated. It could be just one step of factoring. It could be multiple steps of factoring. It just depends. All right, so let's go with that's going to be A. B, x cubed and C. There we go. So like I said, I'm gonna give you about ballpark 10 to 15 minutes, 12 minutes, somewhere in that window to try these 3 out. And then I will go over them after that. So look over your previous instructions. Remember, if the first thing you see is a GCF, take that out. You have those 3 formulas: difference of squares, sum of cubes, difference of cubes. You had the shortcut method, you had the AC method, you had factor by grouping for the 4-term polynomial, which the AC method also used factor by grouping because we took a trinomial and turned it into a 4-term polynomial. All right. All right, I think that's going to be enough time. So for A, the 24x squared minus 16x. Remember that when you factor anything, the process should always start with, do we have a GCF? And then after that, you ask yourself how many terms you have, because that's going to determine your method from there. And with this problem, there is a GCF. Between 24x squared and 16x, between 24 and 16, you can take out an 8. So there's a GCF. 8 between 24 and 16, and between x squared and x, you can take out an x. So we write the GCF first. Then we open a parentheses and we divide each term by that GCF. 24 divided by 8 is 3. X squared divided by x is x. Then we have a minus. 16 divided by 8 is 2, and x divided by x cancels, so that would be it. And then, once you take your GCF, you look at what's inside the parentheses and you say, well, can I do anything else? All right, this is a binomial. Binomials with a formula is like a difference of squares or sum of difference of cubes. I don't have any exponents like 2s or 3s or higher, which means we're done. This is as far as you can take it. This is the answer. That's all we can do. Sometimes all we can do is take out a GCF. How about for B? We got x cubed minus 8. So first question, is there a GCF? This one's got x's, but the second one doesn't. The second one's got an 8, but the first one doesn't have any numbers that are also divisible by 8 besides 1, which would be pointless most of the time. So there is no GCF. So you say, okay, how many terms do we have? We have a binomial, 2 terms, which means it could be one of those formulas. It could be prime. Remember, some things are not factorable, and we call them prime. I see a 3 of an exponent, which is a giant flag that it's going to be a cubes formula. With a minus here, it means it's probably a difference of cubes. Now, those formulas were given to you previously, and we said the sum and difference of cubes formulas were very similar. They both had the pattern of a squared, ab, b squared, and then we use SOAP to get the signs for the in between the first 2 terms, and then the third and fourth term and the fourth and fifth term. All right, so our A would be x, and our B is, because x cubed is x cubed, it sounds redundant. And then what number cubed makes 8? Well, it's 2. So we go, parentheses, A, B, and another parentheses, A squared, A times B, and then B squared. Then we use SOAP, don't forget SOAP, same opposite, always positive. The original sign was a minus, so the first sign is the same as that. The second sign is opposite of that, so a plus, and the third, no matter what, is always positive. And then we just clean this up, we get x minus 2 times x squared plus 2x plus 4. Now you might try and factor the x squared plus 2x plus 4. You'd try a shortcut method, factor pairs of 4 would be 1 times 4, 2 times 2, which add to 5 and 4, neither of which is a 2, which means it's prime. I did mention briefly a couple classes ago, that when you do a cubes formula, the trinomial piece is always prime for us. So you don't have to worry about that. C. 1, 2, 3 terms. There's no GCF, so we call that a trinomial. And because there is a leading coefficient of 1, because we don't see a number written, we assume it's a 1, we're going to use the shortcut method, which is where we take the number at the end, we list all its factor pairs, and then try and add or subtract it based on that sign to make the middle number. So we're going to go to the side. We write a plus 26, which has multiples of 1 times 26 or 2 times 13. We're trying to add these pairs because that's a plus to make a 27. 2 and 13 add to 15, that's a no. 1 and 26 add 27, so that's a yes. But we need to give these values appropriate signs to make a negative 27. Well, if we choose these to both be positive, that makes a positive 27. That's a no. If we make them opposite signs, the product would be negative, which is a no. They both need to be negative. Negative 1 plus negative 26 is negative 27. So we go x minus 1 times x minus 26. We don't have to split the middle term and factor by grouping. Sure, you can, but we call it a shortcut because that's the shortcut. All right, let's do some more. Let's do 3 more. Let's go with 20x cubed minus 45x, I think. Yes. E, we're going to go with 3x squared in the front. What did I want this to be? 16 at the back. A minus. This is a minus. (22x). And yeah, that's right. X squared minus 3x plus 40. All right, so once again, going to give you about 15 minutes to try these on your own, and then we'll come back and do them. So again, process, see if there's a GCF, then count the terms. Binomials are formulas, trinomials are shortcut or AC method, 4-term polynomials is the factor by grouping method. That's all we have so far. If you know trial and error, you can use it. We will talk about that a little bit at the end, but it's not a method that I like to spend a lot of time on. All right, good luck. All right, hopefully that was enough time. So let's see what we got here. 20x cubed minus 45x. You might come out of the gate and say it's a binomial, which it is. Before you do that, you should notice that there was a GCF for this one. Between 20 and 45, you can knock out a 5. And between x cubed and x, you can take out a single x. All right. So what do? We write the GCF first. Then we open a parentheses, and we divide each term by the GCF. 20 divided by 5 is 4. X cubed divided by x is x squared. Then a minus. 45 divided by 5 is 9. X divided by x cancels. And now at this point, we have inside a binomial. So that's one of the 3 formulas, probably. And because there's an exponent of a 2, it's probably a difference of squares. Where your a is going to be 2x, because if you square 2 in x, you get 4x squared. And your b is going to be 3, because if you square 3, you get 9. Now here's what some people might do. They'll go 2x plus 3 times 2x minus 3, and then they'll box this up and they get the answer wrong. This is wrong. Why is it wrong? Because they rushed and they forgot to bring down their GCF. You got to bring that home. But don't forget your 5x in the front. That would be the completed answer. D. E, I'm probably going to take up this whole space over here. So we'll do F a little lower. E, 3x squared minus 22x minus 16. Get in this habit. Is there a GCF? Why no, Mr. Beckner? There is no GCF. So count the terms. Well, it's a trinomial, which, by the way, this was a binomial. And the leading coefficient is not a 1. So that means we need to use the AC method. So we take our A times our C, which is 3 times negative 16, which is a negative 48. Let me give myself more room. I said I was giving myself all that room. Let me actually put it over here. So again, this is still going to be part of E. A times C is 3 times negative 16, which is negative 48. Again, that was the 3 times the negative 16. Factor pairs, 1 times 48. 2 times 24, 3 times 16, obviously, 4 times 12, 5 won't go in, 6 will go in 8 times, 7 won't go in, 8 would go in 6 times, so we got them all. We are supposed to be subtracting, because this is a minus, to try and make a 22, specifically a negative 22. So let's subtract the pairs. 48 minus 1 is 47. Nope. 2 and 24 is 22. Yep, that's going to be the pair. Just double check. 16 minus 3 is 13. Nope. 12 minus 4 is 8. Nope. 8 minus 6 is 2. Nope. But these need to make a negative 22. And I gave you a hint previously that the larger number should always be the same as this sign. So it's definitely a negative 24 and a positive 2. Make both negative, they'd make a negative 26. And also the product would be positive and not a negative. So we don't just go x plus 2x minus 24. That would be wrong. We take the 3x squared, we leave it alone. We leave the minus 16 at the end alone. But we split the middle term using these two numbers here. So we go plus 2x minus 24x. The order does not matter. We showed that last class. I'm going with this order. Then we have 1, 2, 3, 4 terms. So we factor by grouping, which means GCF for the first pair, GCF for the second pair, then a GCF, which would be the parentheses, hopefully. Between 3x squared and 2x, you have a GCF of x. 3x squared divided by x is 3x, plus 2x divided by x is 2. So this is our goal. The next parentheses is going to hopefully be a 3x plus 2. Now, I also gave you a hint that this middle sign is going to be what you should take out for your GCF. So we need to take out a minus, and that means we're going to be changing signs. You need to think about that division. Between 24x and 16, we even did these numbers previously. The GCF would be 8. So we're dividing by a negative 8. Negative 24x divided by negative 8 is 3x. Negative 16 divided by negative 8 is a plus 2. How about that? The parentheses match, which means we have a third GCF. Switch colors for illustrative purposes. This is our GCF. What do? We write the GCF first. We open a parentheses. And then we have whatever was left over. Remember, you can just cover these up temporarily. And whatever you have left over is what goes next. I see an X, I see a -8, so X minus 8. And there is our answer. The first parentheses just looks a little goofy. Clean it up. There we go. Finally, x squared minus 3x plus 40. Well, that's a trinomial with no GCF. The leading coefficient is a 1, so we're going to try the shortcut method. So we just take the 40. We list the factor pairs of that. 1 times 40, 2 times 20. 3 won't go in, 4 will go in 10 times, 5 will go in 8 times, 6 and 7 won't go in, 8 would be a repeat, so there we are. And we've got to add the pairs, since that's a plus, to try and make a 3. That's a pretty small number to add to get to. 1 plus 40 is 41, 2 plus 20 is 22, 4 plus 10 is 14, 5 plus 8 is 13. None of those options were a 3. No options work. So that means the original problem can't be factored. We call it prime. One second. And that is an M. It looks like an N, kind of. No. A little better. All right. So that was a decent amount of practice. I'd love to do more, but time is short. And I said that I would show you the trial and error method. And it's exactly like it sounds like. You're going to have to try some or all the options and see which ones don't work until you find the one that works. Error. Try, error. This is going to feel familiar but different. You're still going to be listing factor pairs, but there's going to be 2 things you list factor pairs of. You list your factor pairs of A and C separately. These will be values to place in the first spot of each parentheses, ones that come from A, and second spot of each parentheses. Those come from B. FOIL to see which of your options actually works. Assuming the format goes number times x plus or minus some number, then times a number times x plus or minus. You know what? This looks silly. It's going to look something like that. A binomial times a binomial. You won't have a plus and a minus. It's one or the other. But then there's numbers that go in front of the x's and numbers that go in front of the n's. I mean, look at all the different factored things we've had as answers. 2x plus 3, 2x minus 3, 3x plus 2x minus 8. These are, your variables tend to be in the first spot, numbers in the second spot, sometimes numbers in front of the x's. We have seen one example where there are y's also. So that could be another assumed format if you saw a y squared and a y in there in addition to the x squared and the x. That can happen. And again, the first numbers, these will be the factor pairs from A. And then the numbers at the end are the factor pairs that come from B. This can be not a bad process, but it can be super tedious. It depends on how many factor pairs you have of the A's and the B's. And because of the way things are, let's say you have just one option for the A's and one option for the B's. You might think there's only one option for a possible answer, when in fact there's two. Because when you list the order for the A's, you could have the original way you place the B's, or you could swap them and it leads to a different answer. I will show you what I mean by that. Then you got to get the pluses and minuses right, so you got to be on track with your signed arithmetic. No, let's do a minus. And plus 5x. Yeah, let's do that. 2x squared plus 5x minus 3. So the A is the 2. List the factor pairs of the 2, 1 and 2. Not a lot of options. Your C is 3. List the factor pairs of 3, 1 and 3. And you can write the pluses and the minuses here, although that's going to come in a little bit later. So there's only one option from the A's, there's only one option from the B's, so you might think there's only one possible answer for the factored form. But every time you have an order for the A's, you can swap the order of the B's. So basically it's double what you think. So here's what you got. Your possible answers would go something like this. An X in the first spots with spaces for numbers before and after, or X's in the first spot with spaces for the numbers before and after. So the 1 and the 2, it could go a 1 here and a 2 here. And again, there's no need to swap the order for the A's. But for the B's, it could go 1 here and 3 here, or it could go 3 here and 1 here. In addition to all that, maybe these are both pluses, maybe these are both minuses, maybe they're a mix. And it's these two signs that tell you whether they're both positives, both negatives, or a mix. Let me switch colors. This right here, this minus 3, says that they should be mixed signs. And this sign says the larger product should be positive. Now notice I said larger product, not just the larger number, it's the larger product. That makes a big difference. So you have to think about the outers and the inners as products to really nail this down. So that should be a mixed sign, which means it either goes plus minus or minus plus. Now some students will just go ahead and say, all right, well, let me just write all of these out because I'm not that great with arithmetic. So some students would go one, 1, 2, 2, 1, 3, 3, 1. So some students will just say, all right, let me go. This one could be a plus and then a minus. This one could be a minus and then a plus. Or maybe it goes plus minus, or maybe it goes minus plus. So some students that are better with signed arithmetic will say there's only 2 options. Some students that are less better with it say there's 4 options. Your skill level is going to determine this. So how do we figure these out? We FOIL to check. I really wish I'd given myself a little more room. Let me just label these 1, 2, 3, 4. So for the first one, when you FOIL it, that's 1x times 2x, which is 2x squared. 1x times negative 3, which is negative 3x. 1 times 2, which is positive 2x. 1 times negative 3 is negative 3. Combine your like terms, you get 2x squared minus 1x minus 3. I'm actually going to skip around. I'm going to do 3 next just because I don't want to get the right answer yet. The third one, 1x times 2x is 2x squared. 1x times 3 is a plus 3x. Negative 1 times 2x is a minus 2x. Negative 1 times 3 is a negative 3. Combining like terms gives us 2x squared plus 1x minus 3. Now, neither of these was what we wanted to see. This is what we want to see. The outer and the inner are wrong. One's a positive one, one's a minus one. That's what I was saying, that if you're good with your signed arithmetic and you think about this largest possible product issue, you can avoid half the examples. All right, how about the fourth one? 1x times 2x is 2x squared. 1x times 1 is a plus 1x. Negative 3 times 2 is a negative 6x. Negative 3 times 3 is a minus 3. Combined, you get 2x squared minus 5x minus 3, which again is not what we want. It's close, but that's a minus 5 instead of a plus 5. Now that's a big sign, pun intended, that I just have these signs backwards, most likely. All right, so the second one. 1x times 2x is 2x squared. 1x times negative 1 is negative 1x. 3 times 2 with x's makes a plus 6x with a single x, that is. 3 times negative 1 is a negative 3. Combining, you get 2x squared plus 5x minus 3, which is exactly what we want. So that says 2x squared plus 5x minus 3 has a factored form of this guy. We don't need to write the 1 in front. X plus 3 times 2x minus 1. In fact, in a final answer, you shouldn't write the 1. I just had that there for illustrative purposes. Woo! This is why I'm not a fan of trial and error, at least at this level, unless you've practiced it 100 times. Because once you practice it enough, you can say, all right, I know it's definitely going to be the larger product has to be positive. And if I know the larger product has to be positive, let's just look at the outers and the inners. This one would be a negative 3. This one would be a positive 2. So I know that is not even a possibility. The larger product isn't positive. So it would be this one to use with those particular combinations of numbers. If I look at this one, the inner is a negative 3. The outer, I'm sorry, negative 6. The outer is a positive 1, which would make the larger product negative. So I know this one doesn't actually work. So in reality, it's only 2 good options. But again, I had to be good with my signed arithmetic to understand that. Second. So let's try something with a few more options with trial and error, and that'll be our last problem of the day, I believe. Thinking of how bad I want to make this. Or x squared minus 25x plus 6. So again, we're using trial and error. So we're A, which is 4, positive 4, has factor pairs of 1 times 4, 2 times 2. Or B, which is a plus 6, has factor pairs of 1 times 6, or 2 times 3. Now, if you don't like trial and error, AC method works. You can say 4 times 6 is 24. Try and find the pairs of 24 that add to 25. You choose 1 and 24, boom, 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 and you could go from there. Honestly, more efficient. But some people that are good with numbers can just get this stuff in their head quicker with trial and error. It just depends on who you are, but you have options. And I meant to switch colors for the B. So our options. Well, first of all, let me actually think about the signs. This says that they should be the same signs. And then this says the larger product has to be negative, but if they're the same signs, it's actually easier. They both have to be negatives. So this is an easier case. It's when the last sign's negative that it throws people off more often. Okay, so lots of parentheses. The next in the first spot. There's going to be 1, 2, 3, 4 options, 8 options if you don't know your signed arithmetic well, but we're going to skip those. But just imagine if you did have to actually go through 8 of these. Imagine if you had to go through 20 of these. That's certainly a possibility in the problems that you have to factor in this course. All right, so the A's, it could go 1 and 4, or it could go 2 and 2. And I chose this problem for a particular reason, even though I said there's 4, there's really only 3, and we'll see why. And it's because of symmetry. But each time you have the order of the A's, that way you could swap the B's. The B's could go 1 and 6, or they could go 6 and 1. The B's could go 2 and 3, or they could go 3 and 2. And for the signs, we said they both had to be negative no matter what. These are our options. But look at options 3 and 4. 2x minus 2, 2x minus 3, 2x minus 3, 2x minus 2. These are the same things, just swapped. These are the same, so we don't even need to check the fourth, because the fourth would be the same foiling as the third. So there's really only 3 options here. Well, let's FOIL these bad boys to see which one works. X times 4x would be 4x squared. X times negative 6 would give us negative 6x, right? Negative 1 times 4x would be a negative 4x. Negative 1 times negative 6 is a positive 24. Combine like terms, 4x squared minus 10x plus 24, and that's a no. We're trying to make that minus 25. The first and the last term should end up automatically working. In fact, some people only check the outer and the inner with practice because they recognize that, and that's okay. All right, how about the second one? X times negative 1 would be a negative, x times 4x would be 4x squared. See, I was already going to that. The outer x times negative 1 would be negative 1x. Negative 6 times negative 4 is negative 24x. Negative 6 times negative 4 is positive 24. We know the first is 4x squared. We know the last is 24. Negative 1 plus negative 24 is negative 25x. And that's a yes. That's what we want. I don't even have to check the third one, but just to be safe, I will. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 2 times 2x is negative 4x. I feel like I goofed somewhere. No, that's right. And then negative 2 times negative 3 is a positive 6. Positive, oh, that's, I wrote these as 24s. 6 times 1, 6 times 1. Where did I get 24 from? I'm sorry. Those should have been plus 6s at the end. My apologies. Negative 2 times negative 3 is a plus 6. Combining like terms, you get a 4x squared, then a minus 10x, and then a plus 6, which is a no. In fact, it's coincidentally the same as the first, and that's because there's actually a GCF of 2 in here, and there's a GCF of 2 in here. If you pop those out, you would get the same thing either way. We're not worried about that for now, though. So that says that this was the answer. X minus 6 times 4x minus 1. Now, what's cool is, with practice and skill, I actually knew the first one and the third one failed immediately because they had GCFs inside of one of the parentheses, but there was no GCF in the whole thing. So sometimes you can eliminate answers that way as well. But again, it's just a lot of practice. So I want to make a note of that. Let's just take the third one. Actually, let's do the first one. X minus 1 times 4x minus 6. There's a GCF of 2 in the second parentheses. So you have x minus 1 times 2 times 2x minus 3. We don't want to write that 2 in the middle. We want to write it in front. So 2 times x minus 1 times 2x minus 3. That would actually be the factored form of it, which still does not make the original problem. And once again, if you took the 2 out of this one, even though you're taking it from the first, that's going to give you the x minus 1 that's here. You have the 2x minus 3 that's there. There's your 2 in the front. It ends up being the same. It's kind of fascinating. All right, so with that in mind, we're going to call it a day at this point. I think we had a good decent amount of practice. We did about 10 of these, just shy of 10. Remember, I did set up that P-5 homework assignment. It's a little longer than 1 through 4 or 2 through 4. Yeah, 1 through 4, the others that I gave you, but that's because I feel like you should have more practice with factoring. So when we come to class on Tuesday, we'll start something new. Every now and then we'll throw some factoring in addition to whatever we're doing, because it's just good to practice this every now and then. But I look forward to seeing your wonderful faces on Tuesday in class in the A building. Again, I think it's A111. The only other room it might be is A217, but I'm pretty sure it's A111. All right, take care, everybody, and have a good weekend.